All right, all the preliminary stuff's over. Let's get to like what you probably really want to see. So, I want to create the product class according to the specification on technically on that's specified on page 365. So, at some point in your career, whether it's in this class or not, I'm not sure if this book goes over it. I haven't looked that far ahead, but you have something called, oh, what is it called? Unified Modeling Language, Universal Modeling, Uniform Modeling Language, UML anyway. There's a way to uh, sort of map out in a right brain visual kind of way all kinds of different objects in like IT and computer programming and stuff. One thing you can model with UML is classes. So this is not what this is, but it looks very similar. It's like sort of the same logical arrangement. So on 365, you see that you have the members of a part, and keep in mind, members of a class. This is part of encapsulation. Encapsulation, again, is when you bind things up together, wrap them up in a box kind of, or package, data and the methods that work on the data, or the methods that do whatever in the object. Properties are also part of that in C#, because properties are really kind of a special kind of method, and we'll get to that. But it outlines what the properties are, the methods, the constructors, and the class members, the type, all the different data types and stuff. This is kind of like a UML diagram. This is what we're doing right now. But on 367, you can actually see how that's translated into code. I'm going to sort of modify this. I want to show you a stepping stone, because I want to show you in the Java sort of way for a class first, but without doing properties, and then I'll show you why properties are a thing. So a lot of the things will be the same. So if you look on 367, if you want to follow along, you can watch me type a little bit. I'll talk about this as much as I can, and maybe I'll pause a little bit so you don't have to watch me type. So if I remember right, this is like a product number or serial number or whatever. This is a code that uniquely identifies a certain product. So the product number, that's just a string, because it's going to be like probably a combination of numerals and letters, like a social security number. You don't do math with it. You just identify with it. So it should be unique. Then you have a description. It'll be like, this is a 4-inch Phillips screwdriver size, what, it's that kind of thing. That's going to be what the description is going to be. And then you have the price. So this is a very simple, and again, in the real world, if you did have a product class that you were actually using, it would look probably similar to this, but probably not exactly, because depending on what your actual context is, your business rules, what kind of product it is, what the business is like, there would be things that would be very... Ideally, it wouldn't be that specific. You could create one product class. This is sort of the dream, the utopia of object-oriented programming. You think of it, it's like Plato's ideal forms, right? You have something called a product, and these are all the things a product can be, and we can make a class for that, and then we can use it anywhere in programming where we need a product, right? Real life doesn't work that way. The whole code reuse thing is kind of a dream. Most of the time, you can't like take a class that you designed in the past and apply it to a new task, a new program, without at least tweaking something. But so this is a very simplified product, but we'll go with it. So if you'll notice, it does have an explicit parameterless constructor that doesn't really do anything. It just has an empty body. Then it has one that does take arguments. So this is what's called you're overloading the definition of this This is a special kind of method, your constructor, right? You're overloading it to where it can either take no arguments or it can take a bunch. So, and there actually is, if you do control dot, I think there's ways to automatically generate this that I should have probably done, but I don't want to get ahead of myself here. So I'll talk about this. It helps slow my thinking down when I talk about these things if I type it out anyway. So, of course, it also slows down my typing, but that's it. Pros and cons. All right, so this one will take 3 arguments that, and this is the typical thing with constructors, right? You don't have to do this. This is not a law in programming, but it's a typical way that these things are set up. You will see that the parameters for your explicit constructor will associate with the actual fields, and these are called fields by another. I call it. These are called instance variables in my parlance. I like to call them instance variables. Usually, whether they're private or not, I will call them private instance variables like that. Otherwise known as fields. So these are the fields of your class. And the way to think about it in object-oriented terms and just like class design terms is, at its core, if you get down to the soul of the thing, the Atman in Hindu religion, or the atomic core of something, any kind of thing that you can envision as a class that you're designing and you're programming, what is it at its heart? What is it? And what we're saying here, this is what we're declaring when we create this product class. We're saying this is what a product is. A product is a unique code, a description, and a price. That's what a product is when it comes to this program we're writing. So you'll see that this constructor, which is one of the methods, right? It's the thing that gets your product started. If you create a product with this constructor, you're going to initialize those three fields. So there's a relationship there. And it looks like this. This dot code, and this is different from the book, so don't look at the book right now. This dot code, this is how you distinguish between the two. Notice this lowercase letters, and again, don't look at the book because the book's different. I'm not doing the book yet. I'm kind of following along with it, but I'm doing it differently. So when I say this dot, it will look for members of the class. Right, and one of the things that you have as a member of the class is this right here, this thing called code. This code, spelled the same way, it's the same data type, looks exactly the same, right? But this code is not this code. This is a parameter for this method. It only has meaning from here to here. This one does. Here to here. This code right here has meaning from here to here. It has class scope. So you've heard scope used before. You might have learned a little bit about it. You probably forgot a lot about it. Maybe, maybe not. But the scope of this variable and this variable and this variable is anywhere in this class. So, all right, so I was saying if you type, I had to edit there because I said something that's like totally wrong. I do that sometimes. If you type code anywhere in your class, like say here, it knows that you're talking about knows you're talking about this code right here. That's not true here, because if you type code here, it thinks you're talking about that code, the parameter. So blah, 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 blah. So here, if you type it here, because it's inside of this constructor and that parameter exists for this constructor, it thinks you're talking about this one. If I type it up here in this constructor that doesn't have that parameter, it doesn't have this code right here, right? It's empty. It thinks I'm talking about this one. So unless you have a parameter with the same name inside the class, you can type this anywhere from here to here, and it has meaning. But you can see it's already kind of confusing, so much so that my example, I first did the example here and that was wrong. It gets confusing. So one way you can distinguish between the two very easily is like this. Literally like this. You type this code. Whenever you type this code, you're always talking about this one, never about parameters anywhere. So this code gets code. You're like, why don't you name them something else? You could say string C, string D, string P. Then you don't have meaningful variable names. So that's the con of doing it that way, but then you don't have any problem distinguishing between. In other words, if I do let's see, F2 rename and name this C, see how it renamed that one, because that's the one this code is that code, right? But if I do that, that means I can do this, and it knows that I'm talking about the code up here is getting the C right here. So you can use that style if you want. I recommend getting used to this code because that's just how most people do it. So get used to this style. So, and this is true for this constructor, we're going to do this for all of them. So we're just saying that whenever we want to initially create a new product, then we just set these things equal to whatever's passed as parameters to the constructor. So, but this is just to get your thing started, right? And again, don't look at the book because it's got capital P's. It's referring to properties. We're not talking about properties yet. So I'm going to avoid that for now, and then we'll get to that. We'll get to the book code eventually. That's the constructor. We're 10 minutes in. I want to break these up a little bit, so I'm just going to make another part and do the rest of this, maybe a little faster, maybe not, and we'll see. So I'll see you in part 3.